What is up, gang? We're going to look at our next topic in our transformations unit. That's dilations and compositions of transformations. So like doing more than one of our 4 transformations at once. A dilation is a transformation that enlarges or reduces, so makes bigger or makes smaller, a figure so that the image is similar to the pre-image, like the side lengths are proportional, but the size of the object is different. So on a graph, the dilations will be centered around the origin, or the point 0, 0. And when you think about whether or not a dilation is an isometry, we have to think about whether that image and that pre-image are going to be the same size. And obviously, if we're enlarging or reducing something, then they're going to be not congruent, or different sizes. One way that we describe dilations is by using the ratio of the corresponding sides. That's called the scale factor. So when you're finding the scale factor, you're comparing the size of the new image to the old image. So you would have, as a fraction, I know, fractions, but you would have a fraction that has the side length of the image, or the new shape, on the top, and the side length of the pre-image, or the old shape, on the bottom. In general, when you see a scale factor that's bigger than 1, that means that you are enlarging the object, or the dilation is an enlargement. If you have a scale factor that's less than 1, then that dilation is a reduction, so your new image will be smaller than the old. Let's consider an example. So we've got x prime, y prime, z prime is the dilation of x, y, z. So I'm going to use kind of some different colors here. I'm going to make my original object, the one that doesn't have those little prime marks, in red. So right there is my original, or my old, shape. And then my new shape, which is x prime, y prime, z prime, I'll make that in blue. And the question asks me to find the scale factor, or find a fraction that compares the sizes of the old to the new. Sometimes drawing the shapes out as separate pieces can help you answer these questions. So I've got like my original, my pre-image over here in red, and then down here I've drawn separately my blue. From the labeling, I can tell that this pre-image has a side length of 12. And when I go and look at my new picture, or the image, I've got some information that, all right, this part right here is 12, but this part down here is 18. So the entire length of that blue triangle's side is 12 plus 18, or 30. So I haven't answered my question yet. I haven't set up my scale factor, or my fraction that compares new to old. So my new is going to go on top. My new shape, the big blue one, has a side length of 30. And then my old shape, the little red one, had a side length of 12. And when I compare those in a fraction, I typically want to reduce the fraction as much as it'll go. So 30 and 12 are both divisible by 3. So, oh, more than that, they're both divisible by 6. Oh, snap. So 30 divided by 6 is 5, and 12 divided by 6 is 2. So 5 halves, that right there in the circle, that is my scale factor that compares the size of the new, or the blue shape, to the old, which was the little red triangle. We're going to do numbers 1 through 3, that practice in class, but maybe think about if you have questions that you would need to ask before you could be successful on those 3 problems. And we're going to move on to how we see dilations happening in the coordinate plane, so with x and y coordinates. If you were given a graph and you needed to graph a dilation, then to find the image coordinates for the dilation that's centered at the origin, all you're going to have to do is multiply each of the coordinates by your scale factor. So let's do an example of that right now for our notes. We've got a quadrilateral, so a 4-sided shape, and here are the vertices. Here are the points. That one should have a label, A. to find the image, then I'm just going to multiply all these values, all my x's and y's, by my scale factor, which is the number 3. So to find the image of A, I would do negative 2 times 3, or negative 6, 0 times 3, which is still 0. For B, I would do 3 times 0, 0, 3 times 2, 6. Then move on to my next point to get the image. 3 times 2, 6. 3 times 0, 0. Finally, point D, 3 times 0. And last one, 3 times the y-coordinate in D, 3 times negative 2, which is negative 6. So I could go and graph all of these points, and what I would see is a bigger version of the original quadrilateral, because my scale factor is bigger than 3. That's how I know that this is an enlarge, or my scale factor is bigger than 1. Sorry, so that's how I know this is going to be an enlargement. Again, we're going to save this practice here, number 1, on the next page for class, as well as number 2, parts A and B. But just so we're kind of getting familiar with some vocabulary, let's fill in this next little part, a composition of reflection. So that's when you're reflecting something over a line and then reflecting it again. And what you'll end up with is either just translating something or rotating it. Let's look at each of those examples separately. So here's our first case. We're reflecting across 2 parallel lines. So we see this first arrow right here, this guy, which I'm going to outline in red. And the first thing I'm doing to it is I'm flipping it or reflecting it over the line L. And I get a down-facing arrow. And then the next thing, or the second reflection I'm doing, is flipping it over line M. And what happens when I flip something and then flip it again, if I wanted to go just straight from this start to the finish, my third arrow, I could have just translated my object. I could have just taken it and slid it on down to get to my final image. So when you are reflecting something across 2 parallel lines, the final image you get is just a translation of the original pre-image. Second one is if you're reflecting across 2 lines that cross. So my original shape here is triangle ABC. I'm going to flip it over line L, and then I'm going to flip it again over line M. And what you hopefully end up noticing is that if I wanted to flip something across this line and then flip it across line M, I could have gotten straight from my original shape to my A prime, B prime, C prime just by rotating or just by turning the object a little bit. So that would be a rotation when I'm doing the reflection twice. We're saving practice for class on the next page. Save and practice, but our last vocab word to be familiar with when you come into class is a glide reflection. This is a composition, or when you're doing 2 different transformations at once. You're composing a translation, so sliding or gliding something, and a reflection. I bet you couldn't have guessed that just from the name. Ha ha ha. Keep in mind, you always translate before you reflect. And I mean, the easiest way to remember that is it tells you right there in the name. Glide, reflection, glide first, then reflect. We are going to do one of these problems right now as part of our notes, and then the rest we'll complete in class. So I've got 2 pieces of information in order to do a glide reflection. I need to graph the glide reflection image using the translation that I'm given. So here's my first part, the translation, and the reflection line. That's the second piece of information that I'm given. So my first task will be to take each of these points individually and glide. So gliding first. I'm going to take my point D, and I'm going to do this translation. I'm going to move my X point value to the right 3. So I'm starting out here, but I want to move to the right 1, 2, 3. And then the y value, since I don't see like a plus or minus after that, is just going to stay the same. So this is kind of this next place that point D will be. I'm not going to label it D prime because it's not the final location. I still have to reflect across the line x equals 0. But I am going to take my other points. So line L, I'm going to move it 3 spaces, 1, 2, 3, over here to the right. And finally, point M, I'm going to move it 3 spaces, 1, 2, 3, according to the translation that's up there. And I'm going to connect, oh, let's actually make that a dotted line. So, up, 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 up. Right now I've just done the translation, or the glide part of my glide reflection. I still need to reflect over the line x equals 0. So in your head you should be thinking, ooh, x equals 0. What kind of a line is that? What is that? X equals going to be a vertical line. What is x equal to? 0. So that's going to be a vertical line where the x value is 0, aka my y-axis. I just drew that purple line freehand. I think that is pretty good. What I drew in there is my line of reflection. So I have taken my original shape, I glid, I translated it over here to where it is shown in red. Last step, reflect. So point M prime, M is already on the line of reflection, so it actually isn't going to move. It's already on that reflection line, but this point up here where D has translated to is 1, 2 spaces away from my line of reflection, so the image better be 1, 2 spaces away. So there's my D prime. Last one, point M, 1, 2, 3 spaces from the line of reflection, so 1, 2, 3 is where its image is. And actually, sorry, that was point L that went here and then reflected over. So that I just drew is L prime. And I'll connect my dots. My final answer is what's here in the dark blue. To summarize, took my original points, translated them to get the red, flipped them over the line to get my final answer, the blue, my glide reflection. I'll see you all in class where we'll finish up this practice, and you can ask any questions that you might have.